Hello, world. Welcome to another week of DevChat. My name's Chuck. Nice to be here with you. I'm having some issues with my usual Yeti mic, so I'm on the headphone mic. Hopefully, you can still hear me okay. I'm just going to kind of continue forward. This is DevChat. We do this here at Algolia every Tuesday to just talk about things out in the community, around search, around recommendation, do a little bit of live coding, do a little bit of chatting, and just kind of record it all for posterity, see who is interested in it. Anyway, I'm glad you can join me, glad you're watching. And just a few things to go through today. First thing, if you didn't know, StrappyConf is tomorrow. Let's get this out of here so that you guys don't have to deal with a million chucks. So yeah, StrappyConf is tomorrow, and Algolia is a sponsor. So we're going to be hanging out over at StrappyConf in the Algolia booth. Would love for you to come say hi. That's kind of why I've been messing with Strappy a lot the last couple of weeks. I'm going to be doing some live demos at the booth. We're going to be chatting. Maddie's going to stop by, who wrote the community Algolia plugin for Strappy that we've been playing with. So it should be a lot of fun. So if you're going to StrappyConf tomorrow, please come by the Algolia booth and say hi. As far as community-driven content that's out there this week, I got a really nice Twitter DM from, I think it was Alad. I hope I was right. But over at StackBit. And Alad's been, Alad's been playing around with Algolia and Next.js and StackBit, and was doing some kind of fun stuff using the Next.js static site generation, essentially to do kind of like just-in-time page compilation. So this is kind of a fun demo. I haven't had a chance to kick the tires on this one yet, honestly. But it looks like a fun demo where you basically have like 1,000 products in a catalog. And then rather than sort of pre-generating all the pages are generated just in time as you navigate through the site, as you come up through the index and go to like product landing pages. So this is cool. I need to get this up and running because I think Alad and I might try and do some kind of additional, like what else can we do on this? But here, I'll drop the link in the comments so you can take a peek at it, kind of a sneak peek. So again, I haven't played with this one myself, but I love the concept and I'm looking forward to digging into it with Alad. So more to come on that one. I think that's about the only community piece of content that's gone out. As far as what is on the Algolia blog, and I should have had this up ahead of time, but I didn't. For those of you that attended my live coding session with some of the folks over at OpenBase a couple weeks ago, we've kind of continued chatting with those folks. We thought kind of what they were doing was really interesting. As you might have recall, if you actually went to that live coding session, OpenBase, who basically do like a universal catalog of packages for like JavaScript and Python and Rust and sort of all the languages. It's sort of a one-stop shop, so you can search through packages, evaluate them, look at GitHub watches, installs, things like that. They are very much a GraphQL shop, and so we kind of had a chat about what it was like essentially if you kind of are used to consuming GraphQL to be consuming directly from an API like Algolia, and some of the pros and cons of that. So one of the engineers over at OpenBase, let me see here. So we can bring this up. Come on, clicky. was kind enough to kind of walk through with us some of the information about what they did and sort of kind of the pros and cons of going to GraphQL versus going to an API like Algolia. So this is David Lee. He's over on the OpenBase side. He's a front-end engineer. And I'll drop this in the comments too. So this is kind of interesting. A lot of kind of really rubber meets the road type stuff around what it's like to consume from GraphQL, the kind of carving out a space for an API when an API makes more sense, and sort of some of the statistics that they saw switching back and forth between the GraphQL queries and just the direct calls to the index through the Algolia API. So anyway, that's kind of another neat little sort of blog out here. I love that there's a lot of code in here, sort of showing some of the different pieces that had to kind of pivot in order to swap data sources there. So yeah, so those are kind of the two biggest pieces of content this week. You've got GraphQL, and then you've got StackBit. So moving on from content, I brought this up last week, and this is from the Algolia forums. This was Cameron Walder-Booth posted this a little over a week ago. This was a post about frequency-based ranking. And let me just post this in here. So I wish I could say that after the live stream last Tuesday, I went out and spent a lot of time kind of digging in to this and trying to kind of solve the problem. Sadly, I haven't touched it, but I thought this would be kind of a fun thing to kind of maybe dig into today, just to kind of take a look and see what the Algolia engine is doing kind of out of the box with records like this, what we can do to kind of maybe get the results that Cameron was looking for. So first thing I want to do here is, it looks like I'm a little jumpy. I don't know if the stream is jumpy, but probably because I'm running this server in the background. So let's see if we can free up a little bit of resources there. Maybe this will run a little bit better. But yeah, so just to read through this, it says, hi, I'm using Algolia in my Bubble app. Awesome. Bubble for no code is really cool. A lot of fun. I've been seeing actually a couple posts this week about Bubble. I don't know if it was you, Cameron, or if there are other folks that have kind of jumped on board as well, but Bubble plus Algolia seems to be something that we're seeing a pattern of, and maybe we should do something in the future specifically around Bubble. But for today, we're looking at this index, and the goal here is to search through a bunch of keyword tags that users may have linked to their account. So they can be cities, colors, numbers, etc. Right? So here's a record for user 1 with a bunch of tags on it, a record for user 2, a bunch of different tags on it. And as you can see, record number 2 has more Tucsons. So if we do Tucson here, and let me get the bookmark bar off there. So we can see we've got 1 Tucson on record 1, and we've got 5 Tucsons here. Make that a little bigger just in case the stream isn't catching it right. 1 Tucson on user 1, 1, 2, 3, 4, 5 Tucsons on user 2. However, when I search for the Tucson query, user 1 is ranked at top. Struggling with understanding how to refine my exact parameter. I've adjusted and tested multiple times. Not sure why it's not working. Okay. Cool. Yeah. Trying a bunch of different things. More responsive. Sorry, Cameron. I shouted it out on the stream, but I didn't shout out in the forum. That's on me. So we'll go ahead and drop something in here. But let's take a peek at this. What is going on in this index? So let's go ahead. We'll create a new index here. New index called frequency ranking. All right, and we're going to add some records here. Add manually. Let's see. So we'll have 2 users. One we'll call user Alice. Okay. Yeah. Our little machine just is struggling at streaming today. Okay, and then we'll give Alice object ID. Oh man, I'm trying to remember. Is it? I should know this. Is it ID or ID? I forget. Object ID, lowercase. All right. So object ID, that 1. And then tags, and make it that very long string. Let me just make sure that's how the records are built here. There it is, tags text. And it is just a long string. Okay, so go ahead and add that in. Okay, so that's our first record. And then, of course, if you're going to have an Alice, you got to have a Bob. Bob will be 2. And then Bob's tags will include all of these second ones. With all of our Tucsons. Okay, so let's save our 2 records here. Okay, we got our 2 records for Tucson. Both for Bob, we get Bob. And so sure enough, when we do a search for Tucson, our rankings have Alice here with 1 Tucson first, and Bob here with 5 Tucsons second. So, and then we could look, one thing that I was suggesting, I thought I put it on the forum post, but it must not have posted, was that you can go in here at any time if you're looking through the dashboard, and you can see the ranking criteria. So you can see exactly what the engine's doing here and why it's ranking the way it is. So you can see Alice here has 1 matching word in the 49th position, and no other sort of attributes here that work out. And then if we look at Bob, Bob has 1 matching word in the 57th position versus 49th for preceding result. So you can see that the tiebreaker between the 2 is position. So right now, the criteria that the engine is using is that this is the 49th word, I think it was, in that string, as opposed to the 57th. So since this appears later in the string, we arbitrarily decided that that's the one that we should use. So let's go in and take a look at the configuration here, and let's see if we can find a setting that would help us sort of like build this out based on frequency instead. Let's see, deduplication and grouping. I think that's record deduplication. Attribute for distinct attribute used for the deduplication by the distinct feature. So I think that's deduplication in the context of like, if you have, say, like a large piece of text that you split into multiple records or things like that. Okay, well, let's start here with searchable attributes. So we're going to say our searchable attributes are our tags and then our username. Okay, ranking and sorting. Right now, we're just doing pure textual based on all these criteria. Let's add a custom ranking attribute, tags. Let's see, so that's just going to do it based on the tag itself. Let's go take a look at these criteria. Words, number of words from the query that match at least once. Let's see, and we've got that sitting above filters proximity, position matching words, and number of query words matching exactly. Prefix matching. Now, let's see, so none of those are going to actually do it based on frequency. So let's take a peek here. And I'm going to do the I have no idea thing. And let's do a quick search and see Algolia frequency. Rank based on frequency. I believe that's this discourse post. Let's see. So what have you tried already? You have done we moved exact to the top, right? So number of exact matches, and it looks like it's still only counting it once since it doesn't count multiple entries of the same word. And then we've got exact on single word query, controls how the exact ranking criteria is computed when the criteria contains only one word. Default is attribute, alternative is exact. So let's see here. So what can we do? Let's see. Adjusting the exact criterion. By default, exact match occurs when a full word in a query matches a full word in an attribute. I'll make this a little bigger for folks that are reading along. Star Wars is an exact match for Star Wars. Single word matches and multi-word attributes aren't considered exact match. Exact criterion behaves like a counter. If an exact match occurs in an attribute, the exact counter is incremented by 1. Counter works with a single or multi-word query. Every word is treated separately. So thus, if the query contains 2 words and they both match exactly, the exact score of a record is different than the word score because the words criterion takes into account inexact matches. For example, if you query Apple iPhone X, it's 2 exact, score of 1. One caveat to keep in mind is that exact words are only counted once per record. If the same word has 10 exact matches in a record, whether it's in the same attribute or not, the word of the query still gets only 1 point. This means exact is always a number between 0 and the number of words in the query. So this is not what we want for measuring frequency. So the question is, how do we measure frequency? By default, the engine counts singular plurs and single word synonym matches as exact matches. For example, if you have a synonym swimwear, alternative is exact. Keep in mind this practice is really a good read. Alternative is exact, disable exact on attribute, exact on single word query. Okay. Man. So frequency of a word. how do we do this based on the frequency of a word? I wonder if that's even going to be possible here. Let's see, let's go back at that exact criterion again. So one caveat to keep in mind is that exact words are only counted once per record. Okay, so let's check here again. Okay. So here we mentioned term frequency. TF-IDF, statistical weighting scheme based on two elements: term frequency, the number of occurrences of a word in a document, and inverse document frequency. Interesting. Okay, so this may be where we're thinking that it should be fairly easy to do frequency because TF-IDF is kind of baked onto it. Find the schema. Term frequency. I guess these questions give you a much better chance of finding Brad Pitt than a statistical approach like TF-IDF. Interesting. So Algolia doesn't rely on any variation of TF-IDF. Instead, we use these 6 criteria. So it could very well be that by design, we are actually not a great search engine for doing frequency-based searches. So let's see if there's a way that we allow you to sort of do TF-IDF style searches within Algolia. Okay. It doesn't look like we do. Process values. Interesting. So here we're talking about faceted search. So this is, again, sort of taking and faceting on a value. You can either sort by count or alphabetically. This is count across records, though, not count within a single record. I don't think that would help us in this case, too, but let's give it a shot. So if we make, just out of curiosity, see what would happen. We can make tags a faceted attribute. Okay, then we can go back into our browse. Let's see. So we've got these facetable attributes now. Let's see, let's build out a UI for it. Full instance search UI. Oh, I forgot to save my faceting. Let's see here. Go back. Configuration. Facets. Review and save settings. Forgot you have to save in our console. Okay, so now let's create a UI demo. Let's see, let me just edit this one. There we go. Now we can add a filter. Let's see. Actually, let me get out of this. Can we just do it here and browse? Yeah, so you look at, so this is just going to grab that whole value. So faceting is not going to help us here because you just end up with these incredibly complex facets. So I'm not sure if there's a good solution for this using Algolia search without, of course, doing a calculated attribute. So what we could do is, we could essentially aggregate the number of tags on a user here, and then have those aggregates as a complex attribute, right? So basically what we could do is we could go in here. Is there any way to make this UI bigger? Let's see, let's grab Alice here. Bring her over to VS Code. Okay. Like basically what you would have to do is build a more complex. We've got like tags, build that as a complex object. And then you could aggregate by color, right? So like essentially we've got 2 reds. So you could say red 2, blue. And obviously we would want to calculate this, but at what, 4 blue. Choose 1. Get red and blue colored, gray 2. And look at Copilot here doing this math for me. Oh, Copilot is so magical. And shout out to Brian Robinson, who just sold me on this whole Copilot thing. This is just crazy magical. I even second guess you. Yeah. Oh, look, there's one that's wrong. 2 should be 3. 2 should be 3. Sorry, Copilot. All right, let me double check 1 then. 1 should be 4. All right, what we got? 3. 3 should be 1. 4. Where's 1? And 5. 5 is 1. Okay, so with our new sort of computed tag, and object ID, I did here, puts this record. Sorry, someone in chat said VUR, FYI. I don't know what VUR means. If you want to explain further, go for it. And let's see, our second record here. Oh, my tags. Got to take that tag off. Okay, cool. So we've got this more complex tag here. We'll edit this record here with Bob. something similar. I just want to make sure that I've got the structure right for complex attributes. Okay, so there's an array. Handling data relationships. Oh, it looks like it needs to be an array. Let's see. Specified anchorings. We want to flatten this even further then. I thought you could have like a 2-level, like with a dot annotation. Sub attributes. I can remember how to do that. I know there's a dot notation. Where is it? Let's see. Search. Boy, I wish I could remember this. Nested attributes. There it is. Nested attributes. Okay. So, nested attribute. Looks good. And then okay, interesting. So you can't make them searchable via the dashboard either. You have to do it via the API. Okay, that's good to know too. All right, so let's go ahead and build our second record then. Now that we know that we're doing it right. Get Bob here. And then we'll do the same thing to Bob. So red. Got 3 reds. And then blue. Make 2 blue. Oh no, that blue's up there. Oh, let's see. Oh yeah, okay, cool. Say 1 blue. Then on to green. 1, 2, 3, 4 greens. Three purple. It's really interesting about sort of, frequency-based algorithms versus kind of where we're coming from, right? Where we're doing much more based on this sort of 6 different factors around exactitude of matches, positioning, how relevant it is on the placement within the page, and then of course the custom rankings that you can key in, rather than kind of doing, sounds like what is kind of more of a traditional mechanism of going in and doing kind of word count across the entire document, and then sort of scoring based on frequency of words, all kind of those other pieces of it. I think this is kind of something that I've noticed too, as I've been playing with Algolia over the last, 8 months or however long I have been digging into it, is that Algolia is really, really, really good at what we do. But what we do is definitely like sort of prefix-based text search for like your mobile application. I think it's kind of interesting to see some of these other use cases where things are a good fit and where things maybe aren't as good a fit. And this looks like it might be one of those ones where there is a way to get what you want, but it requires doing some pre-calculation and sort of massaging of the records to get the desired outcome. It's just a good thing to know, kind of as you're evaluating Algolia as a search tool for your site. Try out. Boy, I could have written some code for this, but I don't know. I feel like by the time I wrote the code, those extra Tucson's, 1, 2, 3, 4, 5 Tucson's, right? That's kind of where we came into this thing. Anyway, I just feel like this is kind of one of those mid-level tasks where it makes just about as much sense for me to just go ahead and do this manually as it would be to split the field and do the addition and then spit it back out. So, and if those of you at home are following more carefully and I missed one of these, let me know. So I can just go in there. And we already caught those Tucson's. Okay, cool. Put the new Bob in there. New Bob. Interesting. Ah, look at that. Like, why did it generate object IDs? It is capital D. Strange. I swear it was a lowercase d there. And why do you not like my record? 6 is fine. What do you like? Duplicate key 1. Duplicate key 1. Maybe a couple extra ones. We'll add those in here. Key 3. Is that true? Key 3. Put that on here. All right. Unexpected token. Position 327. Tags. What don't you like about my tags? Is it the comma? I didn't think it cared about these commas, but it does. Okay. And then it created a new record because I didn't have that right. Let me edit this one too. Let's fix our IDs, otherwise it's just going to keep generating records. So let's get rid of these. This is, and then this one. Did it delete? Refresh. Okay, cool. Cool. So right now ranked based on object IDs because we're not doing a search. So now if I say Tucson, no results. Let's see. Oh, because that's right, because as they told us, we can no longer use our dashboard for this because tags is now like this complex object. So let's see. Oh. Can we add them all? 5, 4, gray, green, Greenville, Mexico, New York, 1, purple, red. So here we get to the first problem, right? Like if we're allowing users to create their own tags, this is obviously not going to be a tenable management structure to add everyone as a searchable attribute. And let's see, we want these ordered. Let's see, let's find our Tucson. Let's just start there. Okay, so what happens if we look for Tucson now? We don't have results. That still doesn't solve the problem because now those are attribute names. We can't search on attribute names. So they're coming up as tags here now, which is nice. But that's not really helping us. Let's see, let's check our configuration. So we can rank on. Oh yeah, this is going to be a pain. Yeah, I think I've gone down a nasty rabbit hole here. Let's see. So we could rank based on this Tucson tag. So now if I do like search here, this has a Tucson of 5. Did I lose my Tucson? should have a Tucson. I must have missed some of the values there. Let's see, let's give our Tucson a 1 and see what happens. So there we go, tiebreaker Tucson. So we can make ranking criteria, but the challenge is you have to kind of rank on each one individually. And part of this is just Algolia. We're not big on sort of real-time calculation of values. We kind of want to pre-calculate all of this stuff, which is why we need this configuration. So there is a path here around essentially turning each of your tags into a tally attribute, right? And I've done them here as nested, kind of in the hope that I could do maybe something using them as a group. But realistically, this sort of seems this. It's like using essentially slash pathing in an S3 object ID. Like it's not really pathing; it's just a naming convention. It looks like that's kind of what ends up happening here, right? These get flattened in the object itself. So you can't really talk about tags. You have to talk about tags.blue, tags.chartreuse anyway. So yeah, so here is a path forward, but it requires you to have a finite number of tags, right, to pre-calculate essentially these values of number of occurrences of the tags, and then define each individually within your ranking criteria here. So a little rough if you've got dynamic tags or a significant number of tags. Also, it requires a little bit of pre-work. So not really something that you're going to get out of the box. Frequency-based ranking just looks like it's kind of a little antithetical to what we're doing with our engine. And I think, let's see. Why hasn't that shown up in my history? I really would like to look at that blog post again. So this could be some good sort of like homework takeaway from today. And again, I've read this article before, so I think I just need to go back and kind of refresh my memory on it. Let's see. Let me bring it up again. Yeah, this is the one. So something else to look at. This is sort of previous TF-IDF algorithms versus sort of our 6 criteria. So we're looking for specific words. We're looking for proximity if words are close together, right? And particular attributes, right? So depending on how the data is defined within the records themselves. But frequency is not something we take into consideration. So good to know. I do apologize, Cameron, that it looks like I thought I put a message in here as well that I was going to do it on the live stream. I did not. So I will send you an apology, and I will send you sort of all of the different pieces that we looked at today. I was hoping that maybe we would get through this and I would have a little bit of time to play around with building a front end for the Strappy backend that we made last week. As you might recall, we went through this blog post here. Where is that? Yeah, so this is a quick start that basically shows you how to like set up this blog on the back end. using Strappy, and then I took it and added in the Algolia plugin, right? So this is Maddie's plugin here that we'll be talking about tomorrow at StrappyConf. And so I was able to get that in and was able to sort of index some records. Let me show you here. So you can see sort of basically what I did was I went in and republished all the blog posts, so they're all in here. So I did play around with this on my own last week, and I was able to kind of get together, let's see, I think the code sandbox. I was able to sort of put together a front end for this. And this is a Next.js front end. So the quick start kind of walks you through the basics of getting a Next.js based front end kind of up and running. Let's see. Oh, this is the, yeah, do they give you a preview of it here? But anyway, so you go and you sort of build out these article pages and all these different pages. And then what you end up with is front end. Looks a little something like, pop this out. Da, da. So I'll bring this over. This is the one I was working with. Machine is struggling. There we go. So a front end that looks a little something like this. So you can see these are coming out of my, you can see these are the same blog posts that we had published before. There's a couple others in here too. And then what I did was I layered in, went through essentially some information on building out the Algolia autocomplete library is a React component. So I kind of built out this generic React component from some scripts I found in the documentation, and then added it into the nav bar. So my nav bar now has, let's see if we can find, so here's my autocomplete object here, or component. And then I've gone ahead, if you haven't played with autocomplete before, autocomplete, it's source-based. So you can have multiple sources. You can essentially do search across, federated search across multiple sources. Some of those could be Algolia sources. Some of those could be external sources. In this case, I've got an Algolia search here where I'm going through and looking for the articles and sort of returning some results. And then if you put it all together, you end up with a search bar like this, where I can look for love. And you can see we love pizza here. And here's my article about artichokes. And here's an article about shrimp. We love the shrimp, apparently. And so you can then click through, hopefully click through. There we go, and get the blog post. You can also do sort of text-based navigation. So if I say shrimp, I can say enter there without touching my mouse and get to the shrimp article. So this is one of the demos I'll probably be doing tomorrow at the booth, is kind of just talking through how I went ahead and added in this autocomplete component onto the front end. It was pretty straightforward. There were some caveats around sort of getting all the configuration right, and also, of course, making sure that you've got that React component that you can then use alongside your other components. So that's a sneak peek of what I'll be doing at StrappyConf tomorrow. I don't think I actually posted a link to StrappyConf, but let's see if that's even it. Conf.strap.io. Post that in there too. Okay, so I'm going to leave you with that today. Hopefully that was interesting. Cameron, again, apologies that I did not respond in the forum. I will drop that in there. We learned a little something about Algolia's search engine and frequency-based matching. I think more importantly, kind of, it's interesting to see sort of why we do not focus on frequency. We kind of focus on proximity, and positioning and attributes and some of the other components. So it's kind of a good thing to know as you're evaluating Algolia against other engines, looking at, what is a good fit here. Maybe that's a situation where GraphQL might make more sense, right? Where you can do a complex query and then sort of layer it alongside of results that you're getting back from Algolia. Maybe something to continue pursuing on another day. But for today, I'm going to leave you. I hope you have a great rest of your week. Come back and see me again next Tuesday. I'm here every Tuesday around 2 p.m. Eastern time, so about 11 a.m. Pacific time. And, just kind of hanging out. Would love to get some of you to ask some questions. Would be great. Otherwise, we'll just keep dipping into the forums and sort of all the content that's out there. And I will talk to you next time. Take care.